Homework and day session on histograms. So histograms are different to bar charts. They look only a tiny bit similar, where the frequency is given by the area of the bars rather than the height of the bars, which they are in bar charts. Also, the bars can be right next to each other without gaps because we are working with continuous data. We can create and interpret these by remembering some formulas. Class interval width, so the width of the bars is going to equal the range divided by how many class intervals that we want. The range is biggest take away smallest, and in any of our class intervals, if we've got small frequencies, we can actually combine these with class intervals which are next to them, so making that class interval width wider. Now, when we are looking to calculate different parts of it, either the frequency density, or the class interval width, we can use these formulas through this formula triangle. So the frequency equals our frequency density times the width of our bar. The frequency density equals our frequency divided by our class interval width, and our class interval width equals our frequency divided by our frequency density. So we're going to be using these to create and interpret histograms. So we are going to be creating some class intervals from this data here, which is Bill's working hours. These are different shift patterns that he's been working. And just a quick reminder that the width of our bar is going to equal our range divided by the number of intervals that we need. We want 5 intervals, in which case our class interval width is going to equal 11, take away 1, biggest take away smallest, which is 10, divide that by 5, gives me 2. So each one of my widths is going to be a space of 2, but starting from 1 because 1's my smallest value. So it's going to go 1, 3, 5, and so forth. So now I can put this into a table. Here's the data. Now when I ask for a table, some of my learners, unfortunately, they create a table like this. This is not a table that we can use, for the simple fact that if we was working with discrete data, which is what they're trying to here, we would go 1 to 3, 4 to 6, and so on and so forth. But we can't use that because we are dealing with decimals, we're dealing with continuous data. So 3.75, it would have nowhere to go. As opposed to another problem that we've got with this, where we've got 3 within our data range. 3 can go in this box or this box. Now, this builds confusion of exactly where this needs to go. 3 can only go in one box, so we create class intervals allowing it to only go in one box. So here's my table with my class intervals, and now I'm just going to count out how many shifts are equal or greater than 1 but less than 3, and there is 1, 5, 6 and 4. Now I've stopped at this point because I've highlighted the 11 in my table. That's because my class interval here is my hours, or my time is greater or equal to 9 but less than 11. I've got 11 here, in which case I have to change that class interval, so allowing it to be equal to 11. It's either that or I create another interval here for my 11 to go into. So this has now given me the frequency of 2. Now going to actually calculate frequency densities from this table. So I've got my frequencies and I've got my class intervals. So my frequency density equals my frequency divided by my class interval. So my frequency for my first is 1. My class interval is a width of 2. So 1 divided by 2 gives me 0.5. So my bar is going to be the width of my interval, but the height of 0.5, because when we're dealing with histograms, frequency density is my vertical axis. Doing the same for my others, that has produced this histogram. And as you can see, it's equal class intervals. But I can actually, because there's a couple of low values there, I can combine them with classes that are next to them. So it's going to create unequal class intervals. So now my class intervals will go from 1 to 5, 5 to 7, 7 to 11. And there's a frequency of 6 in each of these. So my first bar is going to be 1.5 high. but it's going to have an interval width of 4. The next bar is going to be 3 high with an interval of 2, and my final bar is going to be a height of 1.5 but a class width of 4, in which case this has created an unequal class interval histogram. So we can actually calculate things like our frequency density. And also we can use this to actually calculate frequency, so working backwards. Here we've got a bar, in which case we can calculate the frequency from the area of the bar. So the class interval here is from 1 to 3, so the class interval width is 2 and the frequency density is 1. In which case frequency equals my frequency density times my class interval width. So my frequency for this interval would be 2. Putting that into a table, I've included all the others with the sums. So I've got 2, 10, 12, 8 and 4. And that will be the completed frequencies for this histogram. So we've now got a different type of problem where we've got an unequal class intervals. And for our example, our class interval of 0 to 20 is 20, going from 0 to 20, and the frequency density is 2. So it's going to be doing the exact same. 2 times 20 equals 40, in which case my frequency from 0 to 20 is 40, and I'm going to do the exact same for all the rest. Even though this is unequal class intervals, we do the exact same process. So we could get different types of problems connected with this. So estimating the number of people whose average speed was between 10 miles an hour and 40 miles an hour. So I've drawn lines going up just to highlight these. If I had to work that out, I've just numbered these 1 and 2, just because 1 has a class interval width of 10 and a frequency density of 2. So 10 times 2 gives me 20. And 2 has a class interval width of 20. It's 6 high, in which case there is 120. So 140 people were between 10 and 40 miles per hour. Different type of problem. So estimating the number of people whose average speed was at least 40 miles per hour. So we're looking a line at 40 and we're looking for the values greater than that. We are going to be doing the exact same process, but the difference here is that we've already got these values within the table. It's only this interval of A that we've had to calculate. So that is 210 people. We can use these to help find frequencies when we've been given some information. So frequency class of 95 to 105 is 40. So we've been given this information. We can actually now find out that the class interval is 10 units long. So every 5 blocks of this would be equal to 20, because I've just halved my 40. Because it was 2 blocks wide, it's only 1 block wide, in which case each block is going to be worth 20. And of course I can use this to calculate the other class intervals. Just in this case I did just literally count the blocks, but I could calculate them also. So if I was given partial information, so here I've got a histogram with a bit of information there, and the only information there that I've got is that it's 100 to 140, and I got 300 on the end, which suggests to me I'd have to add a bar to this. So the class interval width equals frequency divided by frequency density, in which case for the 100 to 140 the frequency is 40. So I've started to put this into a table. It's 40, my class interval width is 40, frequency density of 1 for that interval, in which case now 1 block represents 20. Because it's 2 blocks wide, represents 40, every block must be 20. So for my next interval of 140, from 140 up to the next, I've counted up the blocks, in which case my frequency for that must be 160. Now from there, my class interval width for this is going to be 160 divided by 40, which gives me an interval width of 40, in which case my next one is going to be 180. I'm going to put in 180 into my bar chart, so into my histogram, as well as put this into my class interval. My next one is 480, so I'm working out the exact same. So 480 divided by 6 gives me 80, so my class interval width here is going to be 80. Now, I've got 180 to 260, and my last bar is going to be 20 wide. That's because if I was to fill in the rest of my data, I can now put in that final bars. That's because I was given the 100 to start off with, in which case I've just completed the rest of my working out, and that's completed the bar chart. My last job was obviously to just draw in my final bars. If you like what you see, please subscribe. Thank you very much for watching.